I want to talk to you about the turning points of polynomial functions. We've been talking about the zeros of polynomial functions, and they mean certain things. Well, where the graphs turn are the minimums and maximums of the graph, and they tell us things as well. Now, the minimums and maximums are going to be your y-coordinates, and the local maximum is the y-coordinate of a turning point of the function if the point is higher than all the nearby points. And it's a local minimum if that turning point of the function is lower than all the nearby points. So if we look at this function I have graphed below, this polynomial x to the fourth minus 6x cubed plus 3x squared plus 10x minus 3, we see that it has 4 real zeros. You should be able to pick that out right away. And it turns, it looks like 1, 2, 3 times. There's also a little rule about the turning points. The graph of every polynomial function of degree n, so in our case here we have degree 4, so Rn is 4, we're looking at degree n, has at most n minus 1 turning points. So we know our graph has at most 3 turning points. Now it can have less than this, it has at most 3. If the polynomial has n distinct real zeros, so if our polynomial has all real zeros, then the graph has exactly n minus 1 turning points. So if we look at our graph, we have n distinct real zeros because all of our zeros, 1, 2, 3, 4, we know since we have degree 4 that we're going to have 4 zeros, all 4 of them are real, then we have exactly 3 turning points. So we can approximate how many times this polynomial is going to turn just by looking at the function, just like we could approximate how many possible zeros there were. Now let's take this graph in context. Let's say that this is the graph of a car accelerating. And we just want to look at from time 0, so we're just going to start at 0 to 5. So say the x-axis was time in seconds, and the y-axis was the acceleration of our car. We would know that this is a maximum, and down here my graph doesn't go low enough, but there is a minimum down here. So there's a maximum acceleration and a minimum acceleration. That makes this a local maximum because it is higher than any other points around it, and this as a local minimum. Now this point over here is also a local minimum, but we're not looking at that because we were just looking from 0 to 5. But this graph in its entirety has 2 local minimums and 1 local maximum.